pleasure of introducing our speakers today and trying to keep everyone on a very tight timeline. My name is Richard Marshall. I'm a principal with WS Atkins based here in Dubai. But our first speaker today is Mr. Shaun Killa, who is Design Director and Principal Architect and Head of Architecture with WS Atkins and Partners, based here in Dubai. He was part of the team that worked on the Burj Al Arab Hotel. He's won several high-rise commissions, such as the 21st Century Tower, Chelsea Tower, Dubai Flower Centre, Millennium Tower, Must Tower, and a number of others around the Middle East. His design work and management has led to the expansion of the Atkins Dubai studio from 60 to over 500 staff in 7 years. His design specialisation in large projects and high-rise towers and his passion for sustainable design has led him to design the world's first large-scale integration of wind turbines on a building for the Bahrain Trade Center. Shaun, welcome.
Well, good morning. Thank you very much for coming here this morning. It's always a pleasure to speak to so many people and tell about our story that we've been pursuing in the last few years. So, since I have 18 minutes and this is a 45-minute presentation, I'm just going to get going. It might be a bit quick, but you're welcome to ask as many questions as you need to afterwards. Title is Harnessing Energy in Tall Buildings, Bahrain Trade Center, and what we've been up to since then. But first, why should we bother? Well, we've all seen movies like Al Gore's or what's happening in National Geographic about global warming and climate change. And the main factors is that Earth's climate is getting warmer due to additional greenhouse gases in the atmosphere from human activities, principally carbon dioxide released by burning fossil fuels and deforestation. If we continue with economic development based on fossil fuels energy, climate change will continue and accelerate with very damaging consequences. So the depletion of fossil fuels is raising energy costs, which we've seen over the last week especially, and creating a global economy that could cause further wars. So, 8 of the hottest years ever recorded is in fact in the last 10 years, and we presume it will continue. Some of us have seen pictures like this where glaciers are disappearing. So what are we doing about it? Well, most governments are recognizing their ecological footprint, and with the thanks of many different organizations around the world measuring these. As you can see, UAE is one of the top at the moment and trying to do as much as possible to reduce that. The US is not far behind. Now the green line on this graph is actually 2 hectares per person, which is the average ecological footprint. So you can see how many times more the UAE and the States are ahead. A few facts about the building industry, and you'll hear different amounts mentioned perhaps during this conference, but it depends which figures you read. But about 50% of all materials go into construction industry, 60% of timbers and 90% of hardwoods, 40% of all water go into sanitation and other uses in buildings. And 40, and debatably even 60 to 70 perhaps, in generating energy to be used in heat and light and ventilate buildings. So in terms of CO2 emissions, buildings are responsible for between 30 and 35% of CO2 emissions. So we need to find alternatives for our future generations. Of course, we've seen diagrams like this, which describe sustainable design, where you need this sort of tripartite of environment, social, and economic. But to truly be sustainable, one has to go for a holistic approach and literally start from first sketches when designing buildings. Now, I'm going to particularly talk about the environmental and perhaps the active design elements in a building. I'm sure there will be a number of others which talk about passive. However, one cannot ignore passive principles for every building, whether you start thinking about renewables or not. And one very often tends to forget about building orientation and its massing in terms of what it does to reduce heat energy or heat loading. Solar shading, daylighting, thinking about how we can bring light deep into office spaces, or even the massing of the building, how that can affect it, and materials and even microclimates around buildings. Active systems include renewables like wind turbines, photovoltaic energy, global thermal AC and regenerative elevators, and a number of others. Better engineering and recovery systems should be implemented on all buildings, which is to do with recycling and conservation of water and waste, heat recovery, and many other items. Today I'm going to talk specifically about wind energy. Now you might ask why. As a very simple diagram, if this is New York, and 1 square mile is at the bottom of the screen there, if we were to cover 74 hectares of New York, we would only be able to achieve 60% of its electrical needs. For just 10 square miles, we can achieve it with wind energy, and 2 square miles is nuclear. So in terms of space, wind is actually quite efficient. If you look over the other side of the slide, cost and efficiency, wind is still relatively very low compared to solar energy at the moment, which is reducing, and it's very encouraging, but still it's cheaper than nuclear. I'll just move on. So a few examples is the Bahrain Trade Center, as mentioned before, the world's first building ever to integrate large-scale wind turbines. In October 2003, we were asked to master plan a site in Manam in Bahrain with an old 25-year-old Sheraton Hotel shopping center and office building and an unused park. After presenting the concept and the animation to the client, although he didn't ask for a sustainable building, he entirely embraced the concept and went with the journey, which was soon to become very, very exciting for us. The site itself is 330 meters by 250, and you can see at the rear of the site you've got the existing buildings which we had to connect into the rest of the development and increase the shopping area with all of its associated nodes. And then, of course, multi-story car park, and we have a car park over the top of the shopping centre as well to reduce the heat loading on the air-conditioned space. And then to consider the twin towers where we can capture and channel the prevailing winds which come off the Arabian Gulf. Of course, we needed to check this very quickly, so we looked into the windrows of Bahrain, and as I am a sailor, when I went to Bahrain, I noticed that all the time I was there, the wind was coming from the same direction, and it was incredibly strong. And in reviewing the windrows, we found that about 70% of the wind energy in Bahrain was coming from the northwest, which was exactly perpendicular to the sea-facing side of the site. This is mostly due to the convection in the Saudi empty quarter, and the cooler air coming in from the Arabian Gulf is replenishing that air. And in other words, every morning the wind actually comes up in Bahrain, tremendous velocities. So in terms of inspiration, the idea for the towers was to capture the wind and to funnel it between the towers. The towers at the base are 120 meters on either side, and it's channeling into a gap of only 30 meters. So around the bottom you're getting a tremendous acceleration. You're also getting negative energy behind the towers, which is similar to an aeroplane wing, and it actually sucks the air from behind as well. And then of course studying the shape of sails and trying to look at the best ways to carve the wind into or between the building with its least resistance, as well as looking at aspects of when the wind shifts from away from the perpendicular and the effect it has to the area where the turbines are. So from the very initial sketches you can see on the lower part of this slide, we were starting to look at not only when the winds were coming in from perpendicular aspects, but also when they were coming in from 30, 40, and even 60 degrees off axis. Just before I go too much further into the design, the building itself is 120,000 square meters, 42-story towers of 240 meters high each. And you can see in the slightly shaded area where the two towers are within the shopping centre, and there's an atrium space which denotes the entrance to not only the office towers but the shopping centre as well. From this entrance, one can constantly be reminded of the sustainable initiative which the building is taking, as when you look up through the atrium, one would be able to see all three wind turbines turning. In the same case, we've got elevators, panoramic elevators on the edge of the building, which as you ascend up and down the building, you're constantly reminded you're only about 3 meters away from the back of the turbines. So you're reminded about the nature of this building, and we also hope that this would affect a lot of people who actually visit the building to take on a different stance in their lifestyle. In the early stage of design, we started looking at a lot of CFD models, and there were several wind tunnel tests that were made to tweak the building. And it was plainly obvious that when the wind came from the perpendicular, there was an acceleration of up to more than 50%. What became more interesting is as the wind swung from off to 30 degrees off the perpendicular, the wind in the center, or where the turbines are placed, which is here. Sorry, I excuse this is out of focus. But what became even more particular was even up to 60 degrees off the perpendicular, as you can see in the enlargement on the CFD model, that the wind turns and it hits the turbines absolutely perpendicular. And it was all very well and good when we were doing these tests and wind tunnel tests, but in fact a year ago when they were putting up the turbines, the blades, they were measuring for more than 3 weeks. And the turbine manufacturers were absolutely astounded how well the building reacted. In terms of its elevation, the building also is sculpted very much to the needs of the turbines. Because as the wind increases with height, so the buildings at the same time taper and diminish, this reduces the funneling effect on each turbine, and the net result of both of these actually make the turbines run at exactly the same speed and produce the same energy. So when considering integrating wind turbines, one needs to consider if the site is appropriate and if there's enough wind. The type of turbines being horizontal or vertical, and to consider the costs, possible R&D costs and maintenance and power gains. And most importantly is to use standard type-rated turbines. Now there are many schemes which have been presented around the world which don't use off-the-shelf standard turbines. That will immediately lead you into 5 to maybe 10 years of R&D work in producing a new turbine. So one has to not only use that, but understand all of its constraints, the way they yaw, the flicker, noise, vibration. And of course you need a willing manufacturer. So we had all of these at the time of design, but we certainly didn't have a willing manufacturer, so there were many challenges. So after about 6 months, we managed to get Norman and Randall on board to help. In terms of the building's energy and all, I mean, we are managing to produce about 15, maybe even 20-25% of the building's requirement. This equates to about 1,300 megawatts per year, which equates to 55,000 kilograms of carbon per annum. Now, in terms of cost, people say, it might be quite expensive, but it's only 3.5% of the total construction cost. And because of the demand for rental in buildings like this and in the future, with just a modest 10% increase in rental, the turbines and the bridges pay themselves back in 5.5 months. I think I'll just shift through this very quick. These are some of the images as the building was being constructed. In October 2006, the turbines, or at least the generators and the bridges lifted. In March 2007, the turbine blades were lifted. This is what they look like. You can see a small figure at the back of the turbine, so 29 meters is not a small feat. And these are this is images of what the building will look like in less than just a month. In a month's time, all 3 turbines will be turning. At the moment, in fact, there's not enough occupancy in the building to allow all the turbines to run. That will be exceeding the energy requirements for the building. So you'll see that very, very soon. So it's a prototype for a more sustainable world, and it's already become a strong national pride in Bahrain, far beyond what we ever expected. Everybody in Bahrain has embraced this building, and I think to a large degree it's also helped the Middle East awaken to sustainable buildings. So, since then we've been designing buildings in Singapore. This was a competition where we started looking at passive design in terms of its plan. In this sort of area here, where you can see how we're trying to shade the building up to 85% shading. And we also had ideas of having 60 vertical axis turbines in its apex. These are some of the images. Another one was a competition for a 500-meter tower in DIFC, which had 6 47-meter turbines producing each 750 kilowatts, which is equivalent to 4.5 megawatts, plus about 8,000 photovoltaics, another 1.5. In principle, we were looking to generate up to 6 megawatts of energy from this building. And if we could reduce the energy load of the building to a degree of the same, we would almost create a zero-carbon building. Some of the imagery. But to close out, I just want to finish with the Lighthouse. This building actually went onto site 2 weeks ago. They're starting with the enabling works. And it's probably one of our most significant sustainable buildings. It's 400 meters high, commercial building, and we aimed on the onset to reduce the energy consumption by up to 65% and water 40%. We're using the same 3 29-meter wind turbines, which are each 225 kilowatts, and up to 6,000 photovoltaic panels in the spandrel panels between the glazing, the vision panels. We're using regenerative elevators, and in terms of passive and active measures, we're doing a host of things. We are questioning absolutely everything this building has in terms of its shading, the type of glazing specification. The width of the building also allows a lot of natural light to go deep into the space. So we're going to have sensors on the windows, which we probably cut out lighting for a large part of the day. We've got heat recovery systems, we've got chilled beams and chilled ceilings throughout the entire building, which will be a first in the Middle East. And a number of other items. Just in terms of its site, it's behind the gate building. You can see Emirates Towers behind me. And once again, Dubai has a very favourable wind for this particular building, where there's a spike towards the northwesterly onshore breeze. And again, up to about 70% of its energy is coming from the northwest. There's a lot of detail on this slide, but if you want to ask further questions of how we managed to reduce the energy up to 65%, district cooling to about 55, and we even exceeded our aims of the water, reducing water to up to 48%. A lot of shading models and thermal modeling was done on the building to find the optimum places to put PV panels. When we were on the onset, we were thinking of putting the turbines behind direction blades, and as we went into it, it became quite favourable with the way that they were also carving the wind and straightening the wind onto the turbines. But as we went further along, what we found was that there's quite a bit of drag because of these items themselves. So we actually tried taking the turbines out and taking the guide vanes off, and we found that the energy produced was in fact larger, and that changed the design quite dramatically at the top. And because of the slightly lower wind speeds, and that there's no funneling effect as we have on Bahrain Trade Center, we can actually have, I'm almost there, we can have the turbines facing skew winds as well. So just in terms of cost, because a lot of people say, doing buildings like this obviously doesn't work out. In fact, they do, because the cost of the turbines themselves is only 1.5%. of the building. The PV panels about 1%. All the other initiatives with the recovery systems of up to 50% is another 6%. Now this building is going for a LEED Platinum. It will probably be the tallest building in the world with a LEED Platinum rating. The payback with just carbon credits and the reduction in savings is about 7.5 years. If you consider only 10% increase, which was once again quite modest, it's 2.5 years. These are some of the images of the building. In fact, the highest floor of this building will have a visitor centre, and the visitor centre will have all of the initiatives and a library for sustainability. And from there, people can ascend to the top of the tower. In fact, in an elevator that looks, this will be the view, going to a viewing platform at 400 meters. So, I'll just skip past that. Thank you very much. And if you have any further questions, you're welcome to afterwards. Thank you.